Hello, dear students. Today we have Proposition 2 of Book 3. Okay? In a circle, if 2 points be taken at random on the circumference, and those 2 points be joined by a straight line, that straight line falls entirely within the circle. It doesn't go outside the circle. Okay? It seems like a really easy prop, like it's obvious, but for whatever reason, Euclid wants to make sure you see it clearly with your intellect, that there's no doubt in the intellect. Okay? So let this be our circle, and let this be our 2 points taken at random. Okay? Thus, it is required to show that the line, straight line containing these 2 points, falls entirely within the circle. So it's a reductio ad absurdum. And it's going to be weird because we're going to say it doesn't, and we're going to draw this straight line, and it's clearly not straight, but it's the only way we can do it. We're going to grant Mr. Smarty Pants his position. We say this, he says no, so we take his position, and we reduce it to an absurdity of something being equal and not equal at the same time in the same respect, okay? So let's do that. Let's say, okay, we want to join these 2 points with a straight line and let it fall not entirely within the circle. So let that be the straight line that falls outside of the circle, or it can go, you can zigzag, you'll get the same result, okay? And let's take the center of the circle. We know we can do that from Proposition 1. Find the center of a circle, okay? And let's connect the 2 points with the center, each of these 2 points with the center. Okay? Probably can't see that so well, so let me switch to black. Sorry about that. Great. Now, let's randomly connect this straight line, somewhere in this straight line, with the center as well. Let's do that with a different color. Okay, great. Now let's go to our bag of tricks here. We're going to use the proposition that says in any triangle, if there's one angle greater than another angle, that angle which is greater is subtended by the greater side. So if this blue angle is greater than the red angle, the blue line will be greater than the red line. Also, we're going to use an isosceles triangle, the angles at the base are equal. Oops, and there's one other thing we're going to use, and that is the exterior angle of any triangle when the base be extended is greater than either opposite interior angle. So let's do that. Great. Here we have our triangle, right? Remember, this is a straight line because we granted Mr. Smarty Pants in position. And because these are radii of the same circle, these 2 sides are equal. Therefore, we have a triangle. Remember, this is a straight line. Therefore, we have a triangle whose angles at the base are equal. Okay? So we're going to go like this. The angles at the base are equal. These 2 guys are equal. Okay? Now look at this triangle. Remember, this is a straight line. What we have is an exterior angle here. Okay? Of this triangle, the base is extended, so this angle is greater than the opposite interior angle. Remember, in any triangle, the exterior angle is greater than either opposite interior. So this is a triangle, this is a base extended, therefore this angle is greater than this angle. And this angle is equal to this angle because they're angles of this isosceles triangle. Therefore, this being greater than this, and this being equal to this is also greater than this. It's a derivation of 2 things equal to the same thing or equal to each other. Okay? This being greater than this, and this equaling this is also greater than this. So here you have a triangle with one angle greater than the other angle. And we know from our bag of knowledge that in any triangle, the greater angle is subtended by the greater side. So since this is the greater angle, and this subtends the greater angle, and this is the lesser angle, and this subtends the lesser angle, this is greater than this whole line here, all the way down to here. Great. But here we have this circle, and this being a circumference, sorry, this being a radii, this solid red line, not this part, or the solid red line. Therefore, this, and this are all equal, okay? So if this is equal to this, and this is greater than this is also greater than this. But it's also a part of this, so it's less than this. That is to say, it's unequal. So it's greater and less. So it's both less, let's say it's both less and not less at the same time in the same respect. Okay? It's less because it's a part of it, and it's greater than it because the greater angle is subtended by the greater side. Let me make sure I did that right now. Okay, so we have this being greater than this, therefore this is greater than this. But this, being a radii, is equal to this. If this is equal to this being greater than this will also be greater than this. The part greater than the whole. So we know that the part is less than the whole, and here we have the part being not less than the whole and less than the whole at the same time in the same respect. Something cannot both be less than something and not less than something at the same time in the same respect. My brother, who's taller than I am, he can't be taller than me and not taller than me at the same time in the same respect. He can be taller than me and shorter than my oldest brother, but with respect to me, he's either taller or not taller. Likewise with this. This part cannot both be less than the whole and not less than the whole at the same time in the same respect. So we came to this not be and not be at the same time in the same respect. So something we granted must be false. Everything else is clearly true. So the thing we granted, that this is a straight line falling outside the circle, must be false. So the straight line connecting those 2 points must fall entirely within the circle. Quod erat demonstrandum. Let me just say the enunciation again. In any circle, if 2 points be taken at random on the circumference, and you join those two, and those 2 points be joined with a straight line, that straight line falls entirely within the circle. Quod erat demonstrandum. Thank you. Bye.